Romex wire can be used under a deck if specific guidelines are followed. Firstly, the wire must be protected from physical damage. This can be achieved by installing the wire in conduit or using wire mesh to shield it. Secondly, the wire must be rated for outdoor use, meaning it should be moisture and ultraviolet resistant to withstand the elements. Thirdly, the wire must be supported securely to prevent sagging, which could lead to damage or hazards. Romex wire should not be run under siding. Romex wire is not designed for use in exterior locations where it can be exposed to moisture and sunlight, potentially leading to deterioration and electrical hazards. It also may not be suitable for use as a circuit extension because it may lack a ground wire. If you need to run wire under siding, there are several alternatives you can use. One option is to use UF cable, which stands for underground feeder cable. UF cable is specifically rated for outdoor use and direct burial, making it suitable for supplying power to outdoor outlets from inside the home. Another option is to run the wire inside a conduit. A conduit provides a protective enclosure for the wires, shielding them from the elements and providing mechanical support. This method is particularly useful when running wires along exterior walls. A third option is to use a junction box. Install a junction box behind the siding and run the wire from the inside of the home through the junction box to the outside outlets. This method provides a safe and weatherproof connection point for the wiring. When working with electricity, it is crucial to prioritize safety. Firstly, always follow local electrical codes and consult with a qualified electrician for guidance, as codes vary by location. Secondly, use only approved materials and components that are specifically designed for the intended application. Thirdly, take appropriate safety precautions when working with electricity, such as turning off the power at the breaker before working on any wiring. Always ensure that the wiring is properly grounded to prevent electrical shocks. When working with outdoor electrical installations, consider using ground fault circuit interrupter outlets, also known as GFCIs, to protect against electrical shock hazards. GFCI outlets are designed to detect ground faults and quickly shut off the power, preventing serious injury. Consider also using weatherproof covers for outdoor outlets to protect them from moisture and the elements. These covers provide a barrier against rain, snow, and other environmental factors that could damage outlets and create electrical hazards. When selecting wire for outdoor use, choose the appropriate gauge based on the amperage of the circuit and the distance the wire will be run. Refer to the National Electrical Code, also known as the NEC, tables for guidance on wire sizing to ensure that the wire can safely handle the electrical load. The NEC Table 310.15b16 provides ampacity ratings for conductors based on insulation type and temperature rating. For example, a 14-gauge copper wire with THHN insulation is typically rated for 15 amps, while a 12-gauge copper wire with THHN insulation is typically rated for 20 amps. When installing wiring in conduit, use the appropriate size conduit to accommodate the number and size of wires being run. The NEC specifies the maximum number of conductors allowed in different sizes of conduit. For example, Table C, 1N Annex C of the NEC provides the allowable conduit fill for various conduit types and sizes. Use conduit fittings and connectors that are specifically designed for outdoor use to ensure watertight and secure connection. These fittings and connectors are typically made of corrosion-resistant materials such as PVC or stainless steel. When running wires through walls or other structural members, use appropriate bushings or grommets to protect the wires from abrasion. These bushings and grommets prevent the wires from rubbing against sharp edges, which could damage the insulation and create electrical hazards. Always label electrical panels and circuits clearly to identify the purpose of each circuit. This helps to prevent confusion and makes it easier to troubleshoot electrical problems in the future. Use a circuit breaker finder to accurately identify the breaker that controls a specific circuit. This tool can save time and effort when working on electrical installations. When working with electrical boxes, ensure that they are properly grounded to provide a safe path for fault current. Grounding the electrical boxes helps to prevent electrical shocks and minimize the risk of fire. When making wire connections, use appropriate wire connectors such as wire nuts or crimp connectors. These connectors provide a secure and reliable connection that will not loosen over time. Always twist the wires together tightly before applying the wire connector to ensure a good electrical connection. When working with aluminum wire, use connectors that are specifically designed for use with aluminum. Aluminum wire expands and contracts more than copper wire, so it is important to use connectors that can accommodate this movement. Use an antioxidant compound on aluminum wire connections to prevent corrosion. This compound helps to prevent the formation of aluminum oxide, which can reduce the conductivity of the connection. When installing outdoor lighting fixtures, use fixtures that are specifically designed for outdoor use. These fixtures are typically made of weatherproof materials and are designed to withstand the elements. When installing underground wiring, bury the wiring at the proper depth to protect it from damage. The NEC specifies the minimum burial depth for different types of wiring and applications. For example, direct burial UF cable typically requires a minimum burial depth of 12 inches. When backfilling trenches, use clean fill material that is free of rocks and debris to avoid damaging the wiring. Compacting the backfill material helps to prevent settling and ensure that the wiring remains at the proper depth. When installing electrical equipment near water, such as swimming pools or hot tubs, follow all applicable codes and regulations. These codes and regulations are designed to prevent electrical shock hazards and ensure the safety of people using the water. Use a qualified electrician to install any electrical equipment near water. A qualified electrician has the knowledge and experience to ensure that the installation is done safely and correctly. When working with electrical equipment, always use the proper personal protective equipment, including safety glasses, gloves, and insulated tools. This equipment helps to protect you from electrical shock, burns, and other injuries. Always inspect electrical cords and equipment for damage before use. Damaged cords and equipment can pose an electrical shock hazard. Replace any damaged cords or equipment immediately. Never overload electrical circuits. Overloading a circuit can cause the wires to overheat and create a fire hazard. Use a circuit breaker or fuse with the proper amperage rating for the circuit. A circuit breaker or fuse is designed to protect the circuit from overload. If a circuit breaker trips frequently, it may be a sign of an overloaded circuit or a faulty appliance. Have a qualified electrician inspect the circuit to determine the cause of the problem. Never tamper with electrical equipment or wiring. Tampering with electrical equipment or wiring can be dangerous and can create a fire hazard. Always call a qualified electrician to perform any electrical work. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. A qualified electrician can provide guidance and advice to help you stay safe when working with electricity. Remember that electrical safety is everyone's responsibility. By following these safety tips, you can help to prevent electrical accidents and injuries. Always to energize circuits before working on them. Use a voltage tester to verify that the circuit is energized before touching any wires. Use insulated tools when working on electrical circuits. Insulated tools help to protect you from electrical shock. Never work on electrical circuits in wet or damp conditions. Water is a good conductor of electricity and can increase the risk of electrical shock. Keep electrical equipment and wiring dry. Moisture can damage electrical equipment and wiring and create an electrical hazard. Store flammable materials away from electrical equipment and wiring. Flammable materials can ignite if they come into contact with hot electrical equipment or wiring. Have a fire extinguisher readily available in case of an electrical fire. Use a Class C fire extinguisher for electrical fires. Call 911 immediately in case of an electrical emergency. Provide the dispatcher with as much information as possible about the emergency. Know the location of the electrical panel and how to shut off the power in case of an emergency. This information can be critical in preventing further damage or injury. Take a first aid course to learn how to respond to electrical shock and other electrical injuries. Knowing how to provide first aid can save a life. Educate children about electrical safety. Teach children about the dangers of electricity and how to avoid electrical accidents. Supervise children when they are near electrical equipment or wiring. Keep electrical outlets covered when they are not in use. Outlet covers help to prevent children from sticking objects into electrical outlets. Keep electrical cords out of reach of children. Children can chew on electrical cords and get an electrical shock. Check electrical outlets regularly for damage. Damaged electrical outlets can pose an electrical shock hazard. Replace any damaged electrical outlets immediately. Never use extension cords as a permanent wiring solution. Extension cords are intended for temporary use only. Use a qualified electrician to install additional outlets if needed. Avoid running electrical cords under rugs or furniture. This can damage the cords and create a fire hazard. Never overload extension cords. Overloading extension cords can cause them to overheat and create a fire hazard. Use extension cords that are rated for the amount of power that you will be using. Use extension cords with a built-in circuit breaker or fuse. This will help to protect the cord from overload. Inspect extension cords regularly for damage. Replace any damaged extension cords immediately. Unplug extension cords when they are not in use. This will help to save energy and reduce the risk of fire. Never use electrical appliances near water. Electrical appliances can pose an electrical shock hazard when used near water. Keep electrical appliances away from sinks, bathtubs, and showers. Never touch electrical appliances with wet hands. Wet hands can increase the risk of electrical shock. Unplug electrical appliances before cleaning them. This will help to prevent electrical shock. Never immerse electrical appliances in water. Immersion in water can damage the appliance and create an electrical hazard. Have electrical appliances repaired by a qualified technician. Attempting to repair electrical appliances yourself can be dangerous. Follow the manufacturer's instructions when using electrical appliances. The manufacturer's instructions provide important safety information. Use electrical appliances that are certified by a recognized testing laboratory. Certified appliances have been tested to meet safety standards. Look for the UL, ETL, or CSA mark on electrical appliances. These marks indicate that the appliance has been certified by a recognized testing laboratory. Be aware of the potential hazards of electricity. Electricity can be dangerous if it is not used properly. Take the time to learn about electrical safety and follow these safety tips to protect yourself and your family from electrical accidents.